In this video, I want to tell you about how to use neural networks to do multi-class classification where we may have more than one category that we're trying to distinguish amongst. In the last part of the last video where we had the Hamilton digit recognition problem, that was actually a multi-class classification problem because there were 10 possible categories for recognizing the digits from 0 through 9. And so here I want to fill you in on the details of how to do that. The way we do multi-class classification in a neural network is essentially an extension of the one versus all method. So let's say that we have a computer vision example where instead of just trying to recognize cars as in the original example that I started off with, but let's say that we're trying to recognize 4 categories of objects. So given an image, we want to decide if it's a pedestrian, a car, a motorcycle, or a truck. If that's the case, what we would do is we would build a neural network with 4 output units so that our neural network now outputs a vector of 4 numbers. So the output now is actually going to be a vector of 4 numbers. And what we're going to try to do is get the first output unit to classify is the image a pedestrian, yes or no. The second unit to classify is the image a car, yes or no. This unit to classify is the image a motorcycle, yes or no, and this to classify is the image a truck, yes or no. And thus, when the image is of a pedestrian, we would ideally want the network to output 1000. When it's a car, we want it to output 0100. When it's a motorcycle, we get it to, or rather we want it to output 0010, and so on. So this is just like the one versus all method that we talked about when we were describing logistic regression. And here we have essentially 4 logistic regression classifiers, each of which is trying to recognize one of the 4 classes that we want to distinguish amongst. So rearranging the slide a bit, here's our neural network with 4 output units, and those are what we want h of x to be when we have the different images. And the way we're going to represent the training set in these settings is as follows. So when we have a training set with different images of pedestrians, cars, motorcycles, and trucks, what we're going to do in this example is that whereas previously we had written out the labels as y being an integer from 1, 2, 3, or 4, instead of representing y this way, we're going to instead represent y as follows, namely yi will be either 1000 or 0100 or 0100 or 01, depending on what the corresponding image xi is. And so one training example will be one pair xi comma yi, where xi is an image with one of the 4 objects, and yi will be one of these vectors. And hopefully we can find a way to get our neural network to output some value so that h of x is approximately y. And both h of x and yi, both of these are going to be, in our example, 4-dimensional vectors when we have 4 classes. So that's how you get a neural network to do multi-class classification. This wraps up our discussion on how to represent neural networks, that is on our hypothesis representation. In the next set of videos, let's start to talk about how to take a training set and how to automatically learn the parameters of the neural network.